question. I just want to see, just give me a yes or a no in the chat. Did any of you manage, or do any of you have any idea where we can start with a question like this? Anybody got an idea? You can just put, if you're like, no, ma'am, you can just put no in the chat. That's perfectly fine. Or should I give people a few more minutes because there's like 9 people in here? Jasmine, hello. Hello, Jasmine. You're unmuted, but there's no sound coming out, so that worries me a little bit. Okay. Hi, mathmate. I like that word. Hi, Mirula. Okay. All right. I want to address this question because I think it's a really cool question. It was one of the questions that our grade 10s got in their last year's matric, no, I'm saying matric, grade 10 final year paper as the last question that they had. Okay, this was the last question that they had. All right, so here's what we know, guys. Here's what we know. I know that I've got 3 to the power of A must be equal to 21 to the power of B. They must be equal to each other. I know that 7 to the power of C must be equal to 21 to the power of B. However, I know that I want my answer to be B is equal to, I need A and C to be multiplied to each other. Now, these things are in the exponent, right? And at the bottom, I need A plus C to be, and I need A and C to be added to each other. But there must also be a minus somewhere in the middle. There must be a divide between them, right? Let's think about this, guys. If I said to you that I have 3A, right, is equal to 21B to the power of B. If I want A and C right next to each other, how do I then look at this particular part of my question? How am I going to make sure that there's a C multiplied to A? What do I need to put around 3 to the power of A to make sure that there's a C multiplied to it? What kind of operation would need to take place? Anybody got any idea? Teacher Nels, have you got maybe an idea? How do we multiply exponents? What would we have to do to multiply exponents? What would we put around it?
Brackets.
Thank you, Teacher Nelly. A plus, top student of the class, guys. Teacher Nels, she's winning. She's winning. Good. If I want AC, I know that I'm going to have to multiply by C, right? Because then I have a bracket and an exponent, and I can multiply my exponents. But if I do it on the left-hand side, I'm also going to have to do this on the right-hand side. I'm also going to have to multiply by C on this side, right? And then I'm also going to get, that one is also going to go in, right? Hello, Pascal. So now I've got 3 to the power of AC is equal to 21 to the power of BC. Almost nyana kind of there, right? We are almost there. Okay, not really, because we still got a way to go, but that's fine. But I also know that I can split 21. How can I split 21, guys? Oh, shame, Pascal, no worries. How can I split 21? This is an easy question. I'm sure we can all answer this question. What do we think, guys? How do I split 21? Yes, Rulani, correct. It's 3 times 7. It's not even that deep, guys. It's going to be 3 times 7. Good. 3 to the power of AC is equal to. Now I'm going to take my 21 and I'm going to split it into 3 times 7 to the power of BC. And then I have another bracket and exponent, so I'm going to distribute. Remember, 3 has an exponent of 1, 7 has an exponent of 1, so we're going to distribute. I'm going to end up with 3 to the power of AC is equal to 3 to the power of BC multiplied by 7 to the power of BC. Okay, so we're almost there. We know that these two over here have BC or B as a highest common factor. All right, but I also know something else. I know that 7 to the power of C is equal to 21 to the power of B. I've already got a problem here, guys. BC, I've got 7 to the power of BC, but over here I've only got 7 to the power of C. Remember, I took that from there. What do I need to do on this side to get a 7 to the power of BC? Teacher Nels already gave you guys the hint on how to do that part. How do I get this to be B times C on this side? Okay, remember what Teacher Nels did up here. What did Teacher Nels do over here? Yes, Jenna, that's it, brackets. We're going to put brackets around this, and we're going to multiply it with B. And then I'm going to take this, and I'm going to put brackets around it and also multiply it with B. Okay. Now over here, I've got 7C times B will give me BC. 7 to the power of BC is equal to, do not forget, guys, that 21 to the power of B is also equal to 3 to the power of A. So I'm going to take this middle part over here and I'm going to replace it with 3 to the power of A. So I'm going to end up with 3 to the power of A multiplied by B. Okay, so I now have that 7 to the power of BC is equal to 3 to the power of AB. I'm then going to take this and replace it there. Okay, I'm going to replace it over there. So I know that 7 to the power of BC, that now becomes 3 to the power of AB. So I'm going to get 3 to the power of AC is equal to 3 to the power of BC multiplied by 3 to the power of AB. What do we notice? Does anybody see it? Anybody? Anybody? Somebody? Anybody see it? It's what we need every time we want to compare exponents. What do we need? Yes, Kellen, beautiful. We have the same base. And as soon as I have the same base, then I can drop my bases and I can multiply my exponents. I can, not multiply, equate, make my exponents equal. How? Look at me just saying multiply my exponents. Good. So let's clean up this side first. I'm going to go 3 to the power of AC is equal to, like bases being multiplied, I'm going to keep my base and I'm going to add my exponent. So I'm going to get BC plus AB. Now I can drop my exponents. Drop. I'm going to move over to the side a little bit. Right. So now I've got AC. Oh, look at that. We've got an AC. Beautiful. AC is equal to, let me just rewrite that. AC is equal to BC plus AB. But this particular question, guys, wants my answer to be B is equal to something. So what can I do on the right-hand side? I'm actually going to write this up here. Otherwise, I'm going to run out of space. AC is equal to BC plus AB. What can I do on this side over here? The instruction starts with an F. What can we do? Teacher Nels, if anybody looks at your screen, Like if they just look at your face, they're gonna know what the answer is because you're literally just like, yes, you see, Jenna looked at your screen. Jenna looked at your screen. We're going to factorize. Good. So I'm gonna end up with AC is equal to, I'm gonna take B out as a common factor, and I'm gonna have C plus A or A plus C, it won't matter, A plus C. I'm just writing it as A plus C because they have it there as well. I want B on its own, so I'm going to divide both sides by A plus B, A plus C, A plus C, et voila. B is equal to AC over A plus C. On a scale of 1 to 10, 1 being easy, 10 being, ma'am, you might as well have just asked me not to come to school because I'm not writing. How difficult was this test? Or how difficult was this question? On a scale of 1 to 10. 1 being easy, 10 being high. How difficult did we find this question? Mira's like 1 out of 10. Oh, Mirula's confident. Mirula is confident. This question was easy. Remember, guys, 1 means it was easy. 10 means cry face, means just tears. 10 means tears. Jenna's like, the school is foul for putting this on the test. Jenna, it was us. We did it. We put it at the end of the grade 10 November final exam last year. I'm sorry. I'm sorry. But if it's any consolation, there are two kids at our school who managed to get very close. Nobody got the final answer, but there were 2 boys who managed to I think they got 4 out of 6. It was 6 marks. It was a 6-mark question, and 2 of them managed to get 4 out of 6. Okay, so we don't think it was like completely inaccessible. It's just a manipulation of mathematics. Okay, but I thought it was a pretty nice question. All right, welcome to Watobe, everybody. Let's actually get started on today's lesson. I can't believe I traumatized you. First thing we do when we come into class is just traumatize kids. All right. All right, let's just go through rule number 1, which is participate, because we are going to run out of time. But we are doing probability today, so I want you guys to be with me. All right. We are on lesson 4 of 8. Hello, Samsung. You missed the best part of today's lesson. You just missed it. All right, let's start with this question over here, guys. Please answer question 1A and B for me. When you're done, you can pop your favorite emoji in the chat. Also, please let me know if you are stuck, because there's been quite a few people who've been stuck with this question. Sorry, guys, just give me 1 second. I just want to take a quick copy of that.
I'll give you guys 1 more minute. These questions are not that difficult, I don't think. All right, peeps, let's have a look at some of these. Okay, let's start with this first question over here. It says, a fair coin is tossed and a fair 6-sided die is rolled. Okay, it says here, event A is defined as getting tails on a coin. So we know that event A is going to be getting tails, right? Event B is defined as getting an even number on the die. So we know that there are 3 even numbers, 2 or 4 or 6, right? Let's answer this question. Are events A and B mutually exclusive? Yes or no? Pop your answers in the chat. Yes or no? What are we thinking? Yes or no, guys? Okay, let's do this. Yes or no, or I don't know. Rulani says yes. Jenna says no. Okay, anybody else? Yes or no, guys? Cool. The question was this one. Are events A and B mutually exclusive events? Okay, I say no, just like Jenna. Jenna, why do you say no? Let's talk. Why do you say no? Correct. That's it. They're not mutually exclusive because you can get both tails and you can throw excuse me, and you can throw an even number on a die. You can do that at the same time. There's nothing around that. Event A and B can occur at the same time. They can occur at the same time. Okay. Now, I'm just realizing the error of my ways teacher knows.
Are events A and B independent events? Yes or no? Jasmine, what's up?
It could either be yes or no, but preferably no because you can do it at the same time.
Do you mean for A or for B?
For both.
Okay, but we can't say yes or no. It must be one or the other. Okay, let's look at B. It says, are events A and B independent? Okay, I say yes. I want you to justify for me, Jasmine. Why do I say yes?
Okay. Why say yes? Because you could do anyone when you want to.
Correct, but it's not more about the time. If I toss a coin, is my tossing the coin going to affect my answer for rolling the dice?
No.
No, it won't. So that means that these events are actually independent.
Okay. So
Okay,
it's
because
independence
tossing the
because the
coin
time
doesn't affect
would
my
be
answer for.
affected.
Good, that's it, beautiful. That's the answer I'm looking for. All right, the one doesn't affect the outcome of the other. All right. Okay, give me a thumbs up. Does everybody understand why the answers are no and yes? Okay. I just want to make sure that everybody is okay with this. Okay. All right, are we all good, guys? We've got an iPhone in the chat today, in the class today, and I'm not sure who that is. Okay, excellent. Let's answer the following questions. Okay, they say calculate the probability of A something B and A something B. All right, I'll help you guys out. The probability of A and B equals the probability of A multiplied by the probability of B, and the probability of A or B going to be the probability of A plus the probability of B minus the probability of A and B. Okay, I just want to remind you guys that event A is getting tails on a coin, and event B is getting an even number on a die. Okay, you've got 2 minutes, guys. Let me know with a done or an emoji in the chat if you've got the answer I'm looking for. Guys, sorry. Nice emoji. I like that one. Guys, I'll give everybody else 1 more minute. Shouldn't be too difficult. Beautiful glow. All right, let's have a look at this question. All right, so we know that this tiny little thing over here. Oh, I'm sorry, Melissa. Okay, this is the probability of A. What does that mean? What does that symbol over there mean? Good, Bonolo, it means and. So we can use the probability of A and B. We can use the probability of each of those. So we're going to get the probability of A, which is A is tails. So what is the probability of getting tails if I toss a coin? 1/2 multiplied by the probability of B, which is going to be the probability of getting an even number if I roll a dice. That's going to be 3/6. Okay, what is my answer? My answer here is 1/2 times 3/6 should give us 1/4. Okay, let's look at this one over here. This symbol means what? What does the upside down U mean? What does it mean? Good. Ooh, Nolo. Wow, lovely. It means or. So we're going to take the probability of A, which is 1/2, plus the probability of B, which is 3/6, minus the probability of A and B. And we've just calculated the probability of A and B, luckily. So that's going to be minus 1/4. So my answer is then going to be 3/4. Give me a thumbs up in the chat if we're okay with how ma'am answered these questions. Are we all good? Beautiful. Excellent, guys. Okay, excellent. All right, let's look at this next one over here. It says, consider the following Venn diagrams which show how 25 people travel to work. Their travel to work is represented by events B, bicycle, T, train, W, walk. Okay, so B, T, and W, right? Okay. Let's look at this first question over here. Let's all answer this one together. It says here, which events are not mutually exclusive? By the way, who remembers, what does mutually exclusive exactly mean? Maybe let's get a definition so that people... Ha, T means go. I thought it meant train, but okay, we'll take it. We'll take it. Okay. What is mutually exclusive? Which events are not mutually exclusive? Which ones are we seeing that are not mutually exclusive? Good, Jenna. You're onto something there. Okay. Remember, mutually exclusive means that they can't happen at the same time, or they can't both happen. They can't both happen. Okay. So, which two are not mutually exclusive, which means which two can happen at the same time. Rulani, you're thinking of the other way. Mutually exclusive would mean, yes, they must be disjointed. But we are saying which ones are not disjointed. Which two are not disjointed, or which ones are not disjointed? Correct. Which of them do actually meet? How many of them have an intersection? B and T. Okay. All right, let's look at this next one. It says, Mark was asked to answer the following question. One person is chosen at random. Determine the probability of B or T. His solution is given below. Now, this over here is a rule. That's line 1. That's line 1. This is line 2. this is line 3, and this is line 4. Okay, you can look through it carefully. Okay, and then it says here, his teacher said this was wrong and that his mistake was on the 3rd line. Okay, Mark was confused since his formula sheet had the following. Okay, it gave him both the formulas that we need, and there he used them appropriately. Clearly explain and justify to help Mark understand why his solution was incorrect. Now, I want you guys to have a look at his solution. Okay, you can pop your, what do we call them, teacher notes? Your reasons. Pop your reasons in the chat as to why Mark's teacher says that he's wrong. You guys can tell me, why does his teacher say that he's wrong? What do you guys think? Have a look at it carefully. Don't just answer. Okay. I see that, Rulani, but then again, not quite. He didn't, because remember the rule says the probability of B and T should be the probability of the first event multiplied by the probability of the second event. Right. So technically he's not quite wrong, but you are looking in the right place. Tell me why we can say that his calculation is wrong. I want to see if anybody can figure out why. Because, and I'll give you guys a hint, this particular formula is only used in certain instances. We need to figure out which instance that is. What do we think, guys? What are we thinking, guys? Okay, I will show you guys something. Let me show you guys something. Ooh, Bunolo, you're on to something. Okay, let me show you guys something. Do you notice here? Do we notice that here we use the formula? We did. We said the probability of A times the probability of B, right? But before we use this formula, we made some statements. Right? Think about it. We made that statement and we made that statement, that one. Look at the two statements. Okay, think about what we've said here. Think about the reason why we were able to use that formula over here. And now, think about what's happening in this question. No worries, Funzo, welcome. Okay, but Bonolo, you're definitely onto something. Not quite, but just about there. Okay, what are we thinking, guys? Okay, let's think about this. This has nothing to do with mutual. It doesn't have anything to do with mutual exclusivity. Yes or no? Let's look over here. We're looking at B and T. Are these two events mutually exclusive? Yes or no? Are they mutually exclusive? No, Jenna, you're correct. Oh, you're right. They're not mutually exclusive. So we can't say it has something to do with mutual exclusivity, because if they were mutually exclusive, the probability would have to be 0. However, what did we notice about these events up here? The events up here are what? What are they? They are what? Good, Jenna, that's the word I'm looking for. They are independent. Let's go down here. Events B and T, are they independent? Yes or no? Are they independent events? Nolo says no, and I agree with Ponolo. Why can we say no? They are not independent events. Because they have a what? What do they have? Yes, Jasmine.
They have an overlap and it's an intersect.
Correct. There's an intersection. Good. So this formula only works if my two events are independent. But Jasmine, if we look at our Venn diagram, are the events B and T independent? The answer is no, my sweetie. No. Okay, I see. Okay, you are muted, and that's why you're not answering me, but that's perfectly fine. So let's actually do our own calculation, guys. Let's pop your answers in the chat for me. Let's actually calculate for the probability of A. Now I'm saying A. The probability of B or T. The probability of B or T. Okay, remember the formula says that's the probability of B plus the probability of T minus the probability of B intersection with T. Let's go ahead and look for it. I know that the probability of B, how much is the probability of B, guys? If you look at our drawing, remember this is 25 people. So our sample space, our sample size is 25. So what is the probability of taking or choosing the bus to travel to work? Pop your answers in the chat. Okay, remember guys, this is B. This is B. What's the probability of getting B? Not just 9, Bunolo, that's the number of people. But I want the probability. Remember, probability needs to be event over sample. That's it, Jenna. Good. Okay, the probability of B is going to be 9 over 25. What is my probability of T? What's the probability of T? Good, Bonolo. Yeah, that's it. That's the answer. Okay, that I'm looking for. 8 over 25. Beautiful. That's it, Nyeleti. Now let's look at the probability of A and B. That's the intersection. What is the probability of the intersection? A and B. That's it. That's correct. That's it. Good. 5 over 25. So let's put all of this together. I know that the probability of B or T is going to equal to 9 over 25 plus 8 over 25 minus my intersection, which is 5 over 25. So my final answer is actually 12 over 25. Let's go compare this to the answer that Mark got. Look at the answer that Mark got, guys. Two completely different things. Okay. And all of that because we need to make sure that our events are not either dependent or independent. We need to make sure of each of these. Okay. Give me a thumbs up if my explanation of this makes sense, if you're understanding why Mark is wrong. Is everybody okay with this? Beautiful. Okay, here's your next challenge. It's kind of a nice one. All right, it says, using only the symbols A prime, B, P prime, and the words and or, classify the following shaded regions in the given Venn diagrams. Let's start with Venn diagrams 1 and 2. Okay, tell me what we think about number 1. How would we express this using a complement? It just means complement. Sorry, Akwando, it means complement. Good. Funzo, you've got the right idea. Close, like, I like these ones. 3 marks. Good. That's it. And Close says NAD and good. So this is going to be A and B. Good. It means the complement. All right. No, with an E. Complement. Check teacher Nels's spelling. Okay, it's complement. Like that. Okay. Who can remember what's the other word for the complement? The easier word for the complement. What do we call the complement? The easier word. Good, Kellen, that's it. It's not. It's not. Okay, it's the not. So complement, Akwando just means not something. Okay, let's talk about number 2. What's the answer for 2? What do we see? Good, Funzo, that's it. Okay. I hope everybody understands why Funzo says or. Jenna's also saying or. Rulani is also saying or. Good. Go also says or. Excellent. It's because both of them are included, so this becomes A or B. All right. Here's numbers 3 and 4. Let's look at numbers 3 and 4. What do we think of number 3? What's the answer for number 3? Good. Oh, Rulani, you're really good at this. You guys are super, super good at this. Okay, good. Rulani is onto something there. Okay. For number 3, Funzo, not only is B shaded, remember we're looking for the shaded area, but B is not the only thing that's shaded. The outside is also shaded. The whole thing is shaded. What does that tell us? What does that tell us? Okay, let's think about this. Guys, if I had to find the probability of this whole thing, what should the probability of a full event equal? What should the probability of a full event equal? Good, Rulani, it should equal 1, right? So that means that this whole rectangle is 1, but they've minus something from 1. What have they minus from 1? What have they taken out of our full probability? Good, that's it. They've taken A out. They've taken A out. So what we've actually got over here is 1 minus A. What do we call 1 minus A? What do we call 1 minus A, guys? Good, Asbonge, that's it, Rulani, that's it, go, good. A prime or A complement, not A. So what we're considering is everything that is not in A. Okay, that's what that means, A prime. Funzo, be very careful. We cannot say B only. Remember, our instruction says we can only use A complement, B complement, and an or. There's no B only or A only. We can't use it. None of that. Okay, let's look at number 4. I'll show you guys. Number 4 is worth 2 marks. Number 4 is worth 2 marks. So there's a little bit of work to be done here. All right, let's see who can figure it out. No, so we've done and we know exactly what and looks like. That one, the first one, number 1 is what and looks like. So what does that one mean? Okay, let me ask this base question. Yo, Rulani, my word, yes, absolutely. Let me ask this base question, right? We know that they've taken A away. A has definitely been taken away, right? But do you guys notice, right, that they had included B? In order for us to figure out what that B is shaded, they must have included B to begin with, right? But the only way they could take this part of B out is if they included what other part? How could they take that part of B out? Which other part did they include? Which other part did they include? Good, not just not A, the whole of A. Okay, that's how they managed to get that intersection out. How did they manage to get the intersection out? They included A as well. What do we call this? The thing that man has just shaded. What do we call that? What is that called? We've done it above. We've already done it above. What was it called? Not A prime. What do we call this? If I take this one and this one all together, what is that called? A what B? Not quite, Landile. Have a look again. Hello, Landile. If I include both of these, correct, Callan, it is A or B. But they have minus which one? They have minus A. So this then becomes not A or B. Because they've taken the A out of A or B. All right. Okay. Here's the one question that I want us to try again. I don't want us to do contingency tables. I just realized it's a grade 11 concept, and I don't want to confuse you guys. Okay. Excellent, Bonolo. I am glad it does. All right. Here's another questions. All right, here are 3 questions I want us to answer. All right, I'm going to remind you guys that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And the probability of A and B is equal to the probability of A times the probability of B, probability of A multiplied by the probability of B. But we can only use this particular formula for independent events. Independent events. All right. Give this question a try. Pop your favorite emoji in the chat. When you're done, we're going to finish in the next 4 or 5 minutes teacher notes. Okay. I really do need to speak talking. I mean, stop. I wanted to say stop speaking, but then I said speak talking. That was very weird. Okay. Give this one a try. Let me know what you're thinking. Or pop your favorite emoji in the chat when you're ready. Okay. Thank you, Flo. Well done. One more minute. Lwandile, your emoji is exactly how I feel inside. Like you have no idea how appropriate that emoji is, because that's exactly what I feel like. All right, let's have a look at these questions. Okay, so they've given us some sort of information at the top here. So it's very important for us to understand what it is that they mean. Right, so they say here, for events A and B, the probability of A is 0.42, the probability of B is 0.78, and the probability of not A and B is 0.8. Okay, now it says, using the rules of probability, determine the probability of A and B. Please pop your answers in the chat for me. What did we all get? We know that the probability of A and B, or the probability of not something, would have to be 1 minus the probability of the thing. Okay, so I know that the probability of not A and B is equal to 1 minus the probability of A and B. Okay, now I don't have the probability of A and B, that's what I want, but I do have the probability of not A and B. So I'm going to replace this part over here with the probability of not A and B. Okay, I'm going to replace it. I'm going to go 0.8 is equal to 1 minus the probability of A and B. Okay. Then I'm going to take my 1 over to the other side. It's going to become minus. So I'm going to have 0.8 minus 1 is equal to the probability of A and B. 0.8 minus 1 is going to give us 0.2. Therefore, the probability of, negative 0.2, that is also negative the probability of that. That is negative the probability of A and B. Therefore, the probability of A and B is 0.2. So that one is 0.2. There we go. All right. Let's look at, this is A. Let's look at B. Let's look at B. The probability of A or B. But now we've got all the parts that we need because we found the probability of A and B. We can calculate for the probability of A or B. So probability of A or B is equal to the probability of A, which is 0.42, plus the probability of B, which is 0.78, minus the probability of A and B, which is 0.2. Okay. What answer do I get there, guys? Somebody pop that into a calculator for me very quickly and give me an answer. What are we going to get? I suspect 1. Yes, correct. Everybody should get that answer. Thank you, Rulani. The answer is 1. Okay, the answer we should get here is 1. All right. So that makes C very, very easy. Okay, because if we want the probability of not A or B, we know what A or B is. So what is the probability of not A or B? What is the probability of not A or B? If the probability of A or B is 1, remember the probability of, correct, Callan, the probability of not A or B is just going to be 1 minus the probability of A or B, which is 0. the probability of A or B is going to be equal to 0. Okay, all right. That's all that we're going to do today, folks.